With permutations with restrictions, we will generally try to satisfy the restriction before we calculate the number of ways that we can do something. So let's take a look at example 2.5. How many ways can we arrange the letters in the word adding so that the two D's are in front? Well, what do? We imagine we've got, it's our 5-letter word. No, it isn't. It's a 6-letter word, sorry. 1, 2, 3, 4, 5, 6. And we put the two D's in front first. So D, D, right? Then how many ways have I got of arranging the remaining letters? Well, I've actually got 4 distinct letters now. None of them are repeated. So I've got 4 choices for here, 3 choices for here, 2 choices for here, 1 choice for here. So that means my answer to part A is just 4 factorial ways. 4 factorial, of course, being 24. What about part B? If the two D's are together, but not necessarily in front? Well, in this case, we pretend that instead of having the word adding, A-D-D-I-N-G, I've got this word adding, a big, bold D, super D in fact, I-N-G, so just one D. What this represents is the two D's clumped together. So I'm pretending that this is actually equal to D, D, but because they're always moving together, I don't need to think of them as 2 separate D's, I think of them as just one super massive D letter. So then what do I actually have? I have only 5 letters to arrange now, but they are all distinct, right? So I've actually got 5, 4, 3, 2, 1. I've got 5 factorial ways of doing this. I've got 120 ways of arranging them. What about in part C? So that the two D's are separated. Well, if you're trying to do this from first principles, it's a little bit harder, trying to think about, well, how can I keep the two D's apart? Should I assign one and then see where the other one can go? An easy way, that will work eventually, but an easy way of doing this is you look at the total number minus the number of ways that the two D's are together. So this will make our job a lot easier because I can tell you straight off from what we learned in the last section that there would be 6 factorial divided by 2 factorial ways of arranging this. 6 letters divided by the 2 factorial because I've got 2 letters that are identical, the 2 D's. Yep. And then minus away the number of ways that the 2 D's are together, that's just 5 factorial. I found that out in the last question, and that's equal to 240.